Hello and welcome back to the shop. I let you know in the prior video about the other shooting plane that I had bought this one, which is the Stanley 51, and I wanted to do a video about it and the shooting board that I made for it. And let's start a little bit about this plane. It's a very interesting plane. It's a cast iron body, rosewood handle. It was produced between 1909 and 1943 as a number 51 chute board plane. Now, what's interesting is this was sold separately on its own, and the number 52 was this plane with the chute board. So separately, it's considered a 51. But if you see a 52, that refers to the plane and the chute board that Stanley made for it to go in, and that's what it was intended to be used in. It was designed completely around that. Another little interesting thing about this plane is that it has so many patents involved in the creation of it, and I think maybe more than a great deal of the other Stanley planes. It has Leonard Bailey's 1858 lever cap patent. All of these are the different dates of patents prior to the production of this plane. Bailey's 1867 cutter adjustment, Justice Trout's 1888 lateral disc pivot inside to make the blade go left and right, Shade's 1895 the fine frog adjustment, Trout's and Shade's 1896 the plain design patent, Richard's 1902 improved frog, Alex Stanley's 1902 frog receiver, Shade again in 1910 improved the frog adjustment, and Higbee in 1933 for the lever cap. So it took all of these people's designs and patents combined to produce this plane that was then sold later on. So that's one part that's interesting about it. Now, in my prior video, I did a comparison of the Veritas shooting plane that I had at the time. It was returned, and the 62 Stanley that you see here, and the number 9 Nielsen miter plane you see here. And I put this one out because this is one that I've seen quite a few people, the 5.5 Stanley, use as a shooting plane, even though it's got a higher angle to the frog, so the blade is at a higher angle. The 62 is a low angle, extremely low angle. The number 9 is a sort of a moderate in-between angle. And all of these are perpendicular to the bed of the plane, whereas this shooting plane, or chute plane, you see the blade is skewed. And so that makes a difference with it, because when you're using this plane in a chute board, the blade is on this angle, so as it goes across the board, it's pushing down the board and assisting you, as opposed to just going through an adjointing cut. And you'll see how that really helps. So here's the plane. It has the typical adjustment knob for advancing the blade. It has the typical lever cap, and this one is of a type that has the kidney shape. And japanned iron, and you can see the way this is designed as opposed to a normal plane, where this would be the sole, and this would be the profile, or the cheeks. You see it's got a low profile to this cheek here, and then on the opposite side it's got this deep, large piece, which actually is what it rides on. This plane does not ride on its sole. It rides on this centerpiece, so when it goes in a shooting plane, it's seated like that in the shooting plane, in the shooting board, excuse me. And so this surface is just for it to ride on, and this is the cutting surface on the side. So I want to talk to you a little bit about the CHUTE board before we get into really giving you too much of a demonstration of it. But one of the things that provoked me into making my own CHUTE board was there were a couple of CHUTE boards that were made for this, the 52. There were a couple of them for sale, and they were around the 985, which makes it just a hair over 1,000 once you pay taxes and shipping and everything else. And I thought, well, that's an awful lot of money to spend for the CHUTE board. And the other thing about the CHUTE board that bothered me is that it really worked mostly for doing end cuts like this, because the CHUTE board was not that big. So I'm not exactly sure of what the actual largest piece that you could put in there to actually shoot. But I wanted more than that. I wanted to be able to joint with it as well. And I wanted to be able to fit a piece. This is a 20-inch, and I can actually go all the way back to about 22 and be able to peel off a square shaving like that on a longer edge, as opposed to only doing the ends, which it'll work fine for that as well. But that's my motivation for making such a long CHUTE board. Now, let me explain how I did the CHUTE board to you. I'll again come in and get some close-ups for you. But the way I designed it was basically to have all of these pieces here are not glued down. They are all adjustable. So if this starts to wear, I can withdraw this fence, this guard or guide, and I can move it in or out. As well, this piece here is routed into a groove of this lower piece of plywood, and it's screwed from the bottom, and it also can be adjusted in or out, so that if I'm doing a piece here and I really am concerning myself with tear out, and I have a piece right there, I can control the amount of space is left on the board to prevent tear out on the board over here. And so that was important. The other thing is that there's a groove along this edge, so that if any shavings or anything wind up in this bottom tray, they're pushed into this and they're not sitting there to jam the plane in. So that little groove allows a little space for that. And this piece here, this is a piece of solid walnut here. And then this is a piece of 1/4-inch plywood, and it overhangs this edge of the base. And the reason for that is if I want to do a 45-degree a miter on the CHUTE board, all I have to do is to clamp this to the to that overhanging lip out here. And now, when I put a board in, it'll be at a 45. And I can just work it down and get myself to the bevel angle that I want there. But I can remove that whenever I want. Now, I know that there are some people that suggest putting a groove in here to mount that and everything. I don't find the need for it, and I didn't really feel like it was worth the extra work. I also like the idea of being able to adjust this higher so that this still prevents tear out on the end of it. Whereas if I had a groove here and I had a piece of wood sitting there, it's not going to necessarily stop the tear out on a board that's thicker. So that was a consideration.
So here you see my 45-degree angle, and you can see that it easily is adjustable to almost any other angle that I want. But if I were to put those dados or grooves in my board here that were set at 45 this way and this, then making a different angle might be difficult. But with this, all I have to do is make my guide block at whatever angle I want here, and I can attach it there, ending here, and make it as tall as I want to. But this way, I can do whatever angle. If I'm doing a hexagonal shapes or a box or something like that, that angle is totally adjustable, and I'm not locked into just the 45s.
So that was a consideration. The reason this is beveled here is purely so that it gives some support out here, but isn't terribly chunky. And then this is slightly beveled along here, and that's to allow this part here, the blade, to clear this. My hand is well above it, but it allows this blade to clear this board, keeping it low. But I wanted this board to be high enough that it gave plenty of support and wasn't going to pop out with just a thin piece of a guide on the bottom. Now, some people have told me that I should get this frictionless material to put in here, a plastic, and I could, maybe on a second one or something I might, but right now all it has is some wax in there, and you can see that the plane slides quite easily. There's nothing stopping it as far as friction is concerned. So I'm not too concerned about putting the extra expense into this. It was completely made out of scraps from the shop. I've got a hold fast here that keeps it from jiggling on me, and there's a crossboard here that acts like a saw stop that keeps it against the bench, so the board won't go any further that way. It doesn't move that way on me. And again, as you can see, I can do this 20-inch board easily and have no issues with jointing a long board like that. And then, since this is now square, and I've checked it with my actual square, I can turn that side, it's straight, against this end here, and as long as my previous edge is against this fence, I can come in here and clean up the end, and this will be a perfect right angle. As a matter of fact, on some pieces I've taken it all the way around and created a square board, and once you have one edge done, you start turning it around, each one defines the next, and it came out perfectly square. I was really very happy about that. I also tried it on a little piece of ply to see how it would do with that, and it did that very well. Now, you don't get that long shaving, but you can see that it gives you a beautiful surface there. It's pretty simple the way this is made. I'll take this out for a second and I'll show you. It's a piece of 3/4 inch ply on the bottom, and on top of that is a 1/2 inch, a 1/4 inch piece of plywood going underneath this piece of walnut, and then a second 1/4 inch piece on top of that. These are glued in place, including the walnut, but the rest of this is not. If I were to unscrew these 3 screws, you'll find a dado in the bottom of this piece right here, and that is hiding the screws that hold this piece in place. These 2 top screws would remove this top piece of plywood, which is half of this block, and then the bottom half is screwed in from the bottom. So this whole thing can be removed. I don't need to take these out. I can just undo the screws on the bottom and adjust this. The same way with this piece, except this these two are resting on this surface, and this one here is actually down a 1/4 inch into that piece of plywood in a groove going across, which makes it very substantial. And when I did the chute board, I just started by doing this on here, and then this became my guide for putting this piece on. It didn't matter whether it was parallel to this board or not. It's inconsequential. The only thing that mattered is that these two fit snugly to the plane, and then this was adjustable for being able to move it in and out to catch the edge of the plane, so that when I put a board there, I'm not getting tear out. And it's as simple as that. So I want to show you how you can adjust this. If you make this piece, and this is not cutting square, so if you take a shaving off and let's say you discover that that's not square, you put a square up to it, and that is very square. But if anything, it's out a little bit high here, which means the blade is coming this way a little bit. So in order to adjust that, I just use the lateral lever here, and I can just pull the top by bringing it up this way. I bring that top in a little bit. Now, when I check it, it's almost square, but this little bottom part is, well, it's kind of hard to tell. I need to find something that's square here. This has a little bit of cupping to it. So now this is my test block, which has already been flattened here, so I know that that's my that's the surface I'm working off of. And now you can't tell, but I can see that there is absolutely no light showing through this top piece. So this is perfectly square to this edge. This face and this face are perfectly square. So by just adjusting this lateral adjuster, I can control what part of the blade cuts, the lean of the blade. So it's not that important that this be totally square. It is important that the plane and the sole and this side piece is square to each other, but you still have a minor adjustment there that you can use to ensure that you get a nice square corner, and that is what you want. And it's as simple as that. It was about probably $15 worth of scraps, maybe less, all left over from other people's jobs. So, but you can see it works very well, and I can't hope for anything more. Certainly from that chute board that was $1,000. I don't see the reason for that kind of money. This works really well, and I love the extra length.